Hello students, so let's start with the questions of mole concept. So the first question is match list 1 with the list 2. So in the list 1 we have a 52 AMU of helium, 0.5 gram molecule of ammonia, 1 gram molecule of nitrogen and 1.8 gram of water. So we have to match with the list 2 with the relevant things where it is going to be a match with the moles or the atoms. Okay, so 52 AMU of helium. So the 52 AMU of helium and the 52 AMU of helium, if we see 52 AMU of helium, so if we calculate the number of atoms in that, so what is the molecular mass of helium? It is 4. So 52 divided by the 4, it will comes out to be the 13 atoms. 13 atoms. So the A part will match with the second part. So A will match with the second. That is, A will match with the second. Similarly, for part B, that is a 0.5 gram molecule of ammonia. So for the 0.5 gram molecule of ammonia, we take it as a standard temperature pressure as a 22.4, but it is a 0.5 gram, so it will be equal related with the 11.35 liter at STP. So the B part will match with the first. B part will match with the first. And for the C part, it is a 1 gram molecule of nitrogen. So 1 gram molecule of nitrogen for a single atom, it is a 14 grams. For the molecule, it will be a 28 gram. So the C will match with the fourth. Then next, the 1.8 gram of water. So for the 1.8 grams of the water, if we calculate the number of moles in that water, moles of water, it will be equal to 1.8 divided by 18. 1.8 divided by 18, so it will comes out to be the 0.1 mole. 0.1 mole. So the D part will match with the third. D part will match with the third. So A with the second, the B with the first, C with the fourth, and the D with the third. So our correct option is option 2. Next question, the mole fraction of X mole per liter aqueous urea solution is given is, like we have to here calculate the mole fraction of X moles per liter aqueous urea solution. We have given the density of the solution is D gram per ml. So X moles of urea solution, X moles of urea solution contains 1000 ml of solution. 1000 ml of solution. So X moles of urea solution contains a 1000 ml of solution. So here the mass of solution will be equals to, density is given as D gram per ml and it contains a volume of 1000 ml. So the mass of solution will be 1000 of D. 1000 D. And mass of solute will be equal to, it is a urea, so the mass of urea is 60. So it will be 60x. Similarly, the mass of solvent will be equals to mass of solvent will be equal to mass of solution minus mass of solute. So it will be 1000 D minus of 60x. 1000 D minus 60x. And the mole fraction general formula is general formula is that the number of moles of solute divided by number of moles of solute plus number of moles of solvent. So here the number of moles of solute is x moles. So it will be x divided by x plus number of moles of solvent. So the number of moles of solvent will be equal to mass of solvent divided by its molecular mass. So here the mass of solvent is given as 1000 of D, 1000 D minus of 60x, 1000 D minus 60x divided by, here the solvent is water. So the molecular mass of water is 18. So when we solve this value, like when we take this up and multiply all these things, we will get finally as 18x divided by 1000 D minus of 42x. So our correct option will be option first, 18x 1000 D minus 42x. So correct option is option 1. Next question, if 500 ml of the 3 molar solution of glucose is mixed with 500 ml of 1 molar of solution of glucose, the molarity of final solution will be. So here we have to calculate the molarity of the final solution. So molarity of the final solution will be, molarity of final solution will be M1V1 plus M2V2 divided by V1 plus V2. So here M1 is given as 3 into 500 plus 500 into 1 plus 500 into 1 divided by V1 plus V2, that is a 500 plus 500. So it is a 1500 plus 500, that is a 2000 divided by 1000. So it will comes out to be the 2 molar. So our correct answer is 2 molar. Next question is 0.1 molar of NaOH aqueous solution having a density of 1.2 grams per ml will have molality. So we have a clear relation between the molarity and the molality. The molarity and the molarity relation is density divided by molarity is equals to 1 upon molality plus molecular mass divided by 1000. So density in this question is given as a 1.2. So we will put here 1.2. Molarity is given as 0.1. So we will put 0.1 here. This one is the molarity that we have to calculate plus molecular mass. The molecular mass of NaOH is 40. So here it will be 40 divided by 1000. And when we calculate this value, we will get molality will be equals to 0.08 molar. 0.08 molar. So our correct option is option 3rd. Next question, find volume of CO2 gas produced in liter by the combustion of 1 mole of C2H4 gaseous at 1 atm and 273 Kelvin in the nearest integer value. So on the combustion of C2H4, C2H4 plus O2, it gives CO2 plus water. So here carbon is 2, so we will balance it with the 2. And if we see the oxygen here it is 4. Here oxygen is 4, 5 and 6. So here it will be 3. So if we see that a 1 mole of C2H4, that is a 1 mole of C2H4 will gives, that is a 2 moles of CO2. 2 moles of CO2. 1 mole of C2H4 is giving a 2 moles of CO2. So volume at 1 atm, and 273 Kelvin is 22.4 liter. So how much volume of CO2 is required? So 1 mole is giving a 2 mole. So the volume will also get doubled. So it will be 2 into 22.4. 2 into 22.4. So it will comes out to be the 44.8 44.8. But the question here it is asking in the nearest integer, so the answer will be the 45. So answer will be the 45. Next question, identify the temperature independent quantity. So temperature independent quantity, like the quantities which depends on the temperature are linked with the volume, are connected with the volume. So if we see the first term, that is the molarity. Molarity is number of moles divided by volume. Percentage weight by volume is the weight of the solute divided by the volume of the solution. Molality, if we see in the terms of the molality, so it is the number of moles of solute divided by amount of solvent in kg. Amount of solvent in kg. Amount of solvent in kg. So normality is, and the normality is number of gram equivalents of solute divided by volume of solution. So if we see in the first, second and fourth option, these all terms are depending on the volume. So these all are the temperature dependent. Only the one term is independent, that is the molality, because it is not depending on the volume. So our correct option is option third. Next question is the molarity of the solution containing the 2.8% mass by volume. Solution of KOH is given, the atomic mass of potassium is given as 13.9. So molarity is number of moles divided by volume of solution in liter. Here the mass of solute, if we see, so mass is 2.8 grams. Mass is 2.8 grams. And the volume is 100 ml. Volume is 100 ml. Because it is 2.8% mass by volume, that means it is containing the 2.8 gram of solute in 100 ml of solution. Okay. So molarity is number of moles divided by the volume of solution liter. So it is 2.8 into 2.8, and the molecular mass of KOH is 56. The molecular mass of KOH is 56. So it will be 2.8 divided by the 56, and the volume of solution, that is 100 ml. So we have to convert this in the liters. So we will multiply the above value with the 1000. Okay. So this will be cancelled out. And we will 28 divided by the 56. So it will be 0.5. So it will be 0.5 molar. So our correct option will be the option number 2, that is a 0.5 molar. Next question. In a nitration experiment, the 10 gram of benzene gas gives 13.26 grams of nitrobenzene. The percentage yield is in the nearest integer value. So the molecular mass of the benzene, for the benzene it is a 78 gram of benzene. 78 gram of benzene gives 78 grams of benzene gives 123 grams of nitrobenzene. 123 grams of nitrobenzene. So for a 10 gram of benzene, it will be, for the 10 gram of benzene, it will be 123 divided by the 78 into 10. 123 divided by 78 into 10. That comes out to be the 15.77 grams. 15.77 grams. For the percentage yield, it will be the given value divided by the calculated value. So the value which was given through the experiment, the observed, that is a 13.26, and the calculated is 15.77. 15.77. So it will be 13.26 divided by 15.77 into 100, which comes out to be, with the nearest integer, it will comes out to be the 84%. 84%. So the correct answer, so the answer here, it will be the 84. So the answer for this question will be the 84. Next question, what is the molarity of H2SO4 solution that has a density 1.84 gram per centimeter cube at 35 degrees Celsius and contains 98% by weight? So molarity, the formula of molarity, as we have calculated in the earlier question also, molarity is number of moles divided by volume of solution in liters. So that has a density given, and so 98% by weight. So 98% by weight, 98% by weight means that it contains 98 grams of solute, 98 grams of solute in 100 gram of solution, in 100 gram of solution, in 100 grams of solution. So for calculating the moles, number of moles will be the mass upon molecular mass. So the mass here, it is 98, and molecular mass of H2SO4 is also 98. Molecular mass of H2SO4 is also 98. So it will be the 1. So number of moles calculated as 1. Now we have to calculate here the volume. So volume will be density is equals to mass per unit volume. So volume will be mass divided by the density. So here the mass of the solution is 100 and density is given as 1.84 gram, 1.84 grams of per centimeter cube. 100 divided by the 1.84 grams of per centimeter cube. So volumes calculated to be the 100 divided by 1.84. So now the molarity is number of moles, it is 1. The volume is 100 divided by 1.84 and is in the centimeter cube. So we will multiply it with the 1000. And on calculating this calculation, we will get it is 18.4 molar. So the molarity is 18.4 molar. Molarity is 18.4 molar. So our correct option is option 3rd. Next question, X and Y are two elements which forms X2Y3 and X3Y4. If 0.20 moles of X2Y3 weighs 32 grams and 0.4 moles of X3Y4 weighs 92.8 grams, the atomic weights of X and Y are respectively. So here they are the two elements X2Y3 and X3Y4. So we have the moles. So we will use here the general formula of the mole, that is the mole will be equals to mass divided by molecular mass. Mass divided by the molecular mass. So the mole here is 0.20. In the first case, it is 0.20 will be equals to mass is given as a 32 grams, 32, and the molar mass of this compound X2Y3, it will be 2x plus 3y. 2x plus 3y. This is our first equation. Similarly, the second equation, it will be 0.4 equals to 92.8 divided by the molecular mass of X3Y4 will be 3x plus 4y. 3x plus 4y, it will be. So this is our second equation. And solving this two equation, we have to calculate here the unknown parameters x and the y. When we calculate this x and y parameter here, so we will get x will be equals to 56 and y will comes out to be the 16. X will be equals to 56 and y will be equals to 16. So our correct option is option 3rd. Next question, the volume of 0.1 normal dibasic acid sufficient to neutralize the 1 gram of a base that furnishes the 0.04 moles of OH minus in aqueous solution is. So number of equivalents, like for the equivalents of acid equivalents of acid will be equals to the normality into the volume. So the normality is given as a 0.1 normal, normality into volume 0.1, and the volume we have to calculate, so 0.1 into volume of acid, and the neutralization will take place with the base that furnishes the 0.04 moles. So the number of equivalents of base will be equals to number of moles of base, which is given as 0.04. So for the neutralization, the number of equivalents of acid will be equals to number of equivalents of base. So it is 0.1 into volume of acid, is equals to 0.04. So volume of acid from here will be calculated as 400 ml. So our correct option will be the option 1, that is a 400 ml. Next question, an organic compound contains carbon, hydrogen and sulfur. The minimum molecular weight of the compound containing 8% of sulfur is, atomic weight of the sulfur is given as a 32 atm. So the percentage of sulfur will be equal to the weight of sulfur divided by molecular weight of compound into 100. So percentage of sulfur is given as 8. The weight of the sulfur is given as 32. Molecular weight we have to calculate, molecular weight of compound into 100. So it will be cancelled out with the 4. So the molecular weight will comes out to be the 400 grams per mole. So the molecular weight will comes out to be the 400 grams per mole. So our correct option will be the option 3rd. Next question, the 5 liter of an alkane requires a 25 liter of oxygen for its complete combustion. If all volumes are measured at constant temperature and pressure, the alkane is. So we will write the hypothetical combustion reaction, that is the CXHY plus X plus Y by 4 of oxygen. It will give XCO2 plus Y by 2 of H2O. XCO2 plus Y by 2 of H2O. So here the 5 liter of an alkane requires 25 liter of oxygen. So the alkane, the 5 liter of alkane is requiring 25 liter of oxygen. So the 1 liter it will require 5 liter of oxygen. 1 liter will require 5 liter of oxygen. So 5 liter of oxygen, so X plus Y by 4, so X plus Y by 4 will be equals to 5. So this condition of X plus Y by 4 will be equals to 5. It will be satisfied by the propane. That we have to do here, the hypothetically we have to check for that, for which condition it is going to satisfy. So if we take it as a for the propane, so it will be C3H8. So the X value will be here 3 plus 4 by plus y by 4. So 3 plus 2, it will be comes out to be the 5. So this condition is satisfied by the propane, that is a C3H8. So our correct option is option 4, that is a propane. Next question, the ratio of masses of oxygen and nitrogen in a particular gaseous mixture is 1:4. The ratio of number of their molecules is. So the ratio of masses of oxygen and nitrogen is given. So let the mass of oxygen to be X. So similarly for the nitrogen it will be 4x. And if we next we calculate the moles. So moles of oxygen, it will comes out to be the X by 32. And for the nitrogen it will be 4x by 28. 4x by 28, because the molecular mass of nitrogen will be 28. For the molecule calculation, if we have to calculate the molecule here, we will multiply this with the Avogadro number Na. For the molecule calculation, we will multiply it with the Avogadro number Na. And now the ratio of number of their molecules. So ratio of number of molecules will be, so ratio of molecules will be equals to, that is a 1/38, 1/32 is to 4.28. That will comes out to be the 7 divided by 32. 7 divided by the 32. So the ratio here will be the 7:32. So our correct answer is option 3rd, that is 7:32. Next question, a sample of a hydrate of barium chloride weighing 61 gram was heated until all the water of hydration is removed. The dried sample weighed 52 grams. The formula of the hydrated salt is, the atomic mass of barium is given as 137 of AMU and the chlorine is 35.5 AMU. So from here the barium chloride molecular mass will be 208. It will comes out to be the 208. Okay. And that is a sample of a hydrate of barium chloride, that is weighing us 61 gram. Okay, so the hydrated solution of BaCl2, its mass is given as a 61 grams as a mass. Similarly, for the anhydrous barium chloride, it is given as a 52 grams. On calculating the difference of both these two, we will get the amount of water removed, that is 61 minus of 52, it will comes out to be the 9 gram. So the moles of water removed will be equals to the mass divided by the molecular mass of water. So it will be the 9 divided by the 18, that comes out to be the 0.5. It comes out to the 0.5. So percentage of water percentage of water in hydrated barium chloride solution, that is, the amount of water removed is 9 grams divided by the hydrated solution of barium chloride containing a 61 grams of mass. 9 divided by 61 into 100, it comes out to be the 14.7%. So this 14.7% is the percentage of water in the hydrated barium chloride solution. So when this 14.7% is the amount of water, that is the moles of water present. So it is like for the water the molecular mass is 18. So it will be the 18x divided by 18x plus, the addition is with the 208, the molecular mass of barium chloride at 208, and on calculating this we will get the value of x to be 2. So the molecular formula will become BaCl2 dot 2 moles of water. BaCl2 dot 2 moles of water. At the starting we have assumed the BaCl2 dot x moles of water. So finally we get the value of x to be the 2. So it is the BaCl2 dot 2 moles of the water. So our correct option is option number 2.